Chapter 3, Methodology. The automated greenhouse control system is made up of two principal units. First is sensors and actuators. We used Arduino Uno as the microcontroller to which all the sensors and devices are connected and programmed. The sensors measured and sent the current data of the environment to the microcontroller. After the data have been filtered, the microcontroller then compares the collected data with the required ones. If any of the controlled variables is outside a safe limit, the corresponding actuator is activated to restore the optimum condition. In this instant, the Arduino board also reads the states and transmits the information along with the current values of the sensors readings to a LCD for the users to examine whether the system and actuators are performing the anticipated work. All the sensor readings values is flashed in a LCD 1602. In this chapter presents the research method used, research design, schematic and block diagram of the system, conceptual framework and proposed system. These are the materials that we use for this project. First is the one piece Arduino Uno, four pieces of relay channel module, one piece of humidity sensor, one piece of 102 breadboard, cable wires, one piece of RTC module, one piece of photo resistance, one piece of soil sensor, two pieces of container tanks for fertilizer and water, 12-volt source adapter, one piece of 12 volts light bulb, two pieces of 12 volts DC pump, four pieces of 12 volts fan, and one piece LCD 1602 with 11C. And this is our research design. As you can see, there is top view, front view, and side view. This prototype was measured by the dimension of 3 by 3 and the height of 4 inches, 4 in feet, I mean. And this is our conceptual framework. And this is our schematic diagram.
The proposed system of our study, the system consists of various sensors, namely temperature, humidity, light sensors, and soil moisture sensors. These sensors sense various parameters, and then those of it sends to the microcontroller. Here, the Arduino Uno is used, which controls the greenhouse system. To implement the environment of automated greenhouse system, soil moisture sensors, temperature sensors, humidity sensors, etc. are studied. So far, the program has been written onto the microcontroller for specific environment condition. The desired temperature and humidity are maintained by turning on the fans. The fans considered as exhaust and intake fan. The moisture level within soil is also be controlled by turning the water valve on or off. The light control will depend on day or night, which in day and night, the light will off or on. This was automatically detected by the sensors. Hence, the greenhouse system and environment is controlled automatically. The block diagram of the system. The block diagram illustrates the system design with its hardware components involved and connection of sensors and actuators. Here, the main component is the microcontroller Arduino Uno R3. Sensors have been using to gather the parameters for the system to act accordingly. It reads the sensor output and the execute action according to the system of the program. The Arduino Uno can read the analog data from humidity sensor and then turn on or off output according threshold value which is written in the program. The system also receives data from the moisture sensors, then generate digital high or low output according to the program of the system. The microcontroller constantly monitors the digitized parameters of the various sensors and verifies them with the predefined threshold values and check if corrective action is to be taken for the condition at that instant. An array of actuators can be used in the system such as relay, contactors, and changeover switches and so on. They are used to turn on AC devices such as motors, fans, pump, etc.
In this chapter 4, we have the graphical representation and the expected result of the study. The system is developed by the combination of 4 different parts like humidity sensor, light sensor, soil sensor, temperature sensor, water pump, and fertilizers. This is the graphical representation of all the components of our project. Humidity is the presence of water in air. Therefore, to measure both moisture and temperature, this part of the system monitors real-time humidity temperature data from the from the continuously to keep the greenhouse humidity and temperature at desired level. The greenhouse system has some static humidity and temperature levels above and below values. The microcontroller sends corresponding signal to the relay device that turns on the air condition on, on to restore the greenhouse environment humidity and temperature. It takes an analog input from the humidity temperature sensor and provides digital output. The flowchart of 2 different sensors is shown. Next. This is the graphical representation of the humidity sensor. If we look on it, on the first, the system starts, and then the pin 7 is been set for the sensor, the DHT11. Then we have this condition. If the DHT11 is greater than or equal to 35, then the relay or then the relay will be turned on. The R1 is been set for the actuators, which is the fans, to mitigate the temperature in the system. And then the system will or this sensor will be start from the beginning for the next cycle. Next. For the temperature, we use that the same uh, the same principle as the humidity. So the relay for this one is also the fans to uh, to get the temperature of the system on the controlled level. Next. Soil moisture sensor. This section has been used to detect the water level in the corresponding greenhouse. If there is a lack of water in the greenhouse, the detector sends it and sends signal to the microcontroller. The microcontroller sends signal to the corresponding device to turn on the pump. When soil has moisture to a desired level, the microcontroller sends signal to turn off the pump through interfacing the device according to the sensor's output. The program is written on the microcontroller. As the humidity and temperature cycle diagram, we also use that principle in the soil moisture sensor. On this diagram, the R3 is the relay for the water pump. Next. Uh, the next sensor is the light-dependent sensor resistor. The lack of sunlight in a greenhouse is managed by a photoresistor which measures the amount of light on the surrounding and sends signal to the microcontroller. Therefore, the microcontroller sends corresponding signal to the relay device to turn on the lights. Afterwards, when the amount of light is at the desired level, the microcontroller sends signal to turn off the light according to the sensor's output. The switching on and off of the light in the greenhouse depend on the amount of sunlight in the surrounding. The program was written also in a microcontroller. For the light control system, the principle is also used for this system. Now the limit for this is 600. If the reading is greater than or equal 600, then the relay will be turned on, which is the been set as R2, which is the relay for the light.
For the expected result, the project's objective is to develop an automated monitoring system to provide convenience for the users. This study will be beneficial for the user because it can provide or save time for them. Less manpower for tasks, watering the plants, monitoring lights, etc. Also provides safety for the user. Despite of being automated, the project should be maintained and monitored thoroughly by the user. This includes the maintenance of parameters used in the study: sensor, humidity, light, soil, water, including wires connection and the status of sample plant, controlling temperature, light magnitude, and other parameters. Controlling temperature is important for the study. Temperature has big factor for the plant to grow healthy. Temperature outside the prototype or project should be maintained also because it can provide disturbance for the plant growth. Differentiating temperature of the system should be optimized. This will help to determine the relationship between the outside and inside temperature. Controlling the light magnitude or intensity play also an important role in the study. Light is responsible for the plant to be able to undergo photosynthesis. It can also affect the temperature, including the evaporation of the water inside the greenhouse. Humidity control is also important for this study. High level of humidity can destroy the plant. It can be balanced by having a circulation fan in and out of the greenhouse. Water is a must for the plant to grow. The level of water on the soil are monitored by the soil sensor, which then turn the actuator to provide the water needed by the system. All the parameter readings are then flashed on the LCD screen for better monitoring of the system. This project result has many possibilities, but if all requirements of the system has been met, this project will be successful and it can be used for indoors and outdoors cropping.